Hello, my name is ELED313 and this is my science investigation project, which I do have on a poster board, but I left it at home. So my apologies for that. I will upload a picture of it side by side in this video so that you can see the project board as I'm discussing the points. And I do have everything that I did written here. So this is all of that. So for my science investigation project, I did antacid tablets versus temperature, which was how does temperature affect the rate of a simple reaction. So I used 3 different temperatures: boiling water, room temperature, and ice water. And I tested each minute as I dropped the tablet inside the water, how it dissolved and how long it took to dissolve. And for the story that I used, I did Pete the Cat in the super cool science fair, which is where Pete the Cat and his friends decided to do a volcano for a science fair that they had at their school. And while doing the volcano, they had to go through the different trials and error and go see what works, what doesn't work, until they finally got the perfect volcano and they were ready to present it at their school fair. And this story goes along with the 3rd grade science standards that I chose. And the science standards that I chose and that I felt went well with my project, it was 3 different ones. And it was EX, point 3, point P, point 2, understand the properties of matter before and after they undergo change. EX, point 3, point P, point 2, point 4, compare the effect of temperature change on matter. EX, point 3, point P, point 2, point 3, identify processes that result in a physical change. So this is physical science chemistry that 3rd graders can do. And I looked at the project through the lens of a 3rd grader. And the concept was how temperature has an effect on a reaction, a simple reaction, which is the antacid dissolving. So my original prediction was the tablet in the boiling water will dissolve the fastest and the tablet in the ice water will dissolve the slowest. And after some time, I had to make another prediction because the experiment was not going how I thought it would go initially. So I said the tablets will all dissolve by the 30-minute mark. And my hypothesis was if the tablet is dropped in hotter water, then it will dissolve the fastest. It will dissolve faster, I mean. My testable question was how does temperature affect the rate of simple reaction? What is tested is the temperature. What stays the same is the size of the tablet and the amount of water. So I used the Equate antacid tablets that I do have a picture of on my poster board. And the amount of water that I put in, I used the same exact cups, so I was able to put the water to a certain line so that I could know that the water was exactly the same and all the tablets had the chance to be in the same circumstances outside of temperature. The data that I collected was the amount of time it took for the tablet to dissolve. And the materials that we need are ice water, room temperature water, boiling water, Equate antacid tablets, a plastic spoon, which I just used to stir, in the plastic cups that I used to pour the water in and put the tablets inside of. So for my findings, first we're going to talk about the ice water, which that one went how I thought it would, but it still took a lot longer to dissolve than I thought it would, and each time it still did not dissolve completely. It was still almost a full tablet once I reached the 30-minute mark for each trial. So I did it in increments of time. I did 2 minutes, 5 minutes, 10 minutes, 15 minutes, 20 minutes, 25 minutes. then I went up to 30, and eventually 35 minutes. So for the ice water, after dropping it in there, the first few seconds I realized there was minimum bubbling. Um, when I dropped it in there, there was no fizzing up to the top like they usually do. And I guess my first mistake was thinking that these antacid tablets would be like an Alka-Seltzer that we're used to seeing when it's dropped inside of water. It immediately bubbles up, and then within the first 30 seconds is basically gone, depending on the temperature of the water still. So that was something that I found out would not be what I was predicting inside of my head that the project would be like. And after 2 minutes, there was no sign of dissolving. There was no change of color inside the water. It looked exactly like it did when I dropped it in, with the little bit of bubbles. And at that point, at the 2 minute mark, there were no bubbles really. And after 5 minutes, it was still the same. It was basically me looking away, me going back, it still being exactly the same. And at the 10 minutes mark, there was still no change. There was no dissolving of the tablet. There was no more bubbles, no color change in the water. And same thing for the 15-minute mark. So eventually at the 20-minute mark, I was like, okay, I'll stir it with the plastic spoon that was a part of the trial, the first trial I was going through. And I was wanting to see if that would help it break down, like maybe it needed some type of manipulation in order to dissolve better. But even still, it had only dissolved just a little bit, and it gave the water a more orange tint, but the tablet was still kind of large, as if I had just dropped it in that very second. And at the 25-minute mark, the tablet has still not broken down completely. It looked like it was almost whole. There was a little bit of whiteness around it. Like you could see if I stirred it up again that it would break down. But I stirred it up again at the 30-minute mark. It broke down a little more, but at that point the tablet was still whole. So I just realized that if it was in ice water, it may not dissolve completely at all. So next I had went on to the room temperature water, and as soon as I dropped it in there, I noticed some bubbling. It wasn't dramatic like I was expecting it to be again, like it was an Alka-Seltzer. So there was bubbling, so I let it sit there for the first 2 minutes. I came back, there was slight more bubbling, but nothing really dramatic in the room temperature water. After the 5 minutes, the first 5 minutes, the tablet was still whole, no more bubbles were forming. So I was like, oh no, this is gonna be just like the ice water. There's gonna be basically no dissolving unless I go in and try to stir it up again. So I just still wanted to wait the same amount of time that I did for the ice water for the room temperature water, so I didn't go in with the spoon immediately, because I didn't want to kind of like skew the results that I was looking for. After 10 minutes, there was still no change, and the tablet was whole again. Next, the 15 minutes, I let the 5 minutes go by. The tablet was still the same. I came back 5 minutes later at the 20-minute mark to stir it up to see if it would break it down. And it didn't break the tablet down completely, but I could see that the water was dissolving the tablet. It just needed that help to get like the top layer off. So I mixed it up. I noticed the water had an orange tint to it. So I was like, okay, it's dissolving in the room temperature water. And then at the 25-minute mark, I decided to stir it again, and the tablet had dissolved more, but it wasn't completely broken down. So the room temperature water was dissolving the tablet, and at the 25-minute mark, it did make some progress. And at the 30-minute mark, I decided to stir it again. It did dissolve some more, but again, not completely. It was still kind of large, but it did get smaller. The water was changing colors. I could see that the water was starting to dissolve the tablet. And at the 35-minute mark, I didn't stir it again. It still was not broken down completely, but you could see that it was dissolving more. So my prediction of it being dissolved by the 30-minute mark was a failure. It did not work out how I thought it would. And the one I was really waiting for was the boiling water, because I'm like, there's no way that this is not going to dissolve immediately. So I drop it in, and it bubbled immediately. I could see it going, the bubbles going up to the top, and the water changing colors. So I let it sit there because I was getting kind of happy. It was looking really promising. So it sat there for 2 minutes, and then I came back, and it was still only bubbled. It was not broken down completely, but it was smaller. And then after 5 minutes, I saw that it was still bubbling, but it wasn't completely broken down, but you could see the color coming off in the water. And with the pictures that I took of the tablets, I saw that the water was getting more orange than the other two previously had. So I was still excited about seeing if it would be dissolved by the 30-minute mark, and I kind of trusted that it would be. And at the 10-minute mark, the water was turning more orange, but it was still whole. So I was like, okay, I still have to wait until the 20-minute mark in order to go in and stir it. And so I let it sit there 5 more minutes. I went and looked at it at the 15-minute mark, and there was still no change in the fact that the tablet had not dissolved at all. Well, not completely. It did dissolve some because the water was turning orange. And at the 20-minute mark, I came back and I stirred the water to see if it would break down. And the tablet did dissolve almost completely. I think it's sitting in that one spot kind of just had it floating in one area, but it did need to be manipulated. Just like the other two times when I stirred it, I realized that it did have a small change inside of the tablet. So the water was way more orange because it almost dissolved completely at the 20-minute mark. But there was still like a small piece left. And at the 25-minute mark, I stirred it again, and the tablet had broken down completely, and it dissolved into the boiling water. And I was like, finally, by the 30-minute mark, at least one of the tablets was already dissolved. So for my findings, I seen that with a little bit of manipulation at the 25-minute mark, the tablet that's inside of the boiling water will completely dissolve. And at the 35-minute mark for the room temperature water, there was still a tablet left. It was not completely broken down. It was not dissolved completely into the water. So it was still there after the first time I did it. The second time I did it, like, there was no change about the fact that it was gonna not dissolve completely in room temperature water. And same thing for the ice water. With the manipulation, I seen that it did help it, but it was not going to completely dissolve. So for my findings, my results, I saw that temperature does affect the rate of a simple reaction. If it sat there any longer, it may have dissolved completely, but I didn't really wait an hour or 2 hours to see if it would completely dissolve because I kind of lost faith that it would. So those are my results for the experiment. Temperature does have an effect on the rate of a simple reaction, and through the eyes of a third grader, I felt like this was a good experiment because it was something simple that they could do at home with their families, of course, because we are dealing with boiling water and children can get hurt by that. So they will be able to go through and do the different trials, make sure that the subjects, the variables stayed the same, the size of the tablet and the amount of water, and they could have went through and changed the way that the amount of time that they boiled the water. They could have maybe boiled the water longer and made it hotter, and that could have helped it dissolve faster than 25 minutes from what I found. But I let my water boil for the same amount of time. It's like when I'm cooking, I boil it for like 5 minutes, 10 minutes, depending on the pot. The pot I used was a mid-sized pot, so I was able to let it boil for about 5 to 8 minutes and brought it to a rolling boil, and then I put it inside the cup and I dropped the tablet in there. So yes, that has been my project. I will upload the picture of the poster board so that you can see the way I set it up, my pictures, and all of that. Again, my name is Jayla Teachy. Thank you so much for your time, and